Hey friends, long time no see. All right, so I know you're gonna be shocked to hear this, but I decided to do something different right now. Just now, I decided to change the whole lesson plan. So I spent the last 10 minutes creating a new lesson plan. Okay. Um, so here's what we're gonna do. Let's do this. Okay. Today we're gonna do what I changed into. Okay. Tomorrow, no, not tomorrow. Thursday manana. We're gonna do. What do we do Thursday in lab? I know what we're gonna do next week. Next week's gonna be a review session, okay? Because we're gonna have a test the week after. That's gonna be the midterm stuff, okay? I don't want to like give you a whole bunch of new information, but I don't want you to be like super behind on stuff. So here's what we're doing today. Today is gonna be I'm gonna give you a bonus lecture. That's an exciting way to frame it. It's a bonus lecture, okay? So, for those of you who are watching this on YouTube and you're 2 minutes in and you're like, I don't need no stupid bonus lecture, log off. None of this is on the test, okay? And if you're here now, log off if you don't want to hear a bonus lecture. It'll hurt my feelings, but feel free to go. We don't want you anyway because you don't like anatomy. But today, this is going to be just a quick, I'm going to give like a 20-minute, maybe 30-minute lecture on embryology. Okay, we're going to talk that real quick. Um, and here's why. Embryology is so helpful to learning anatomy. It sounds like extra work, and it is extra work, but if you can understand like how the body develops, you can understand things like you can work out problems ahead of time. Like if I wanted you to tell me um, where the blood supply, uh, like the blood supply for like the colon or something like that. Like what is it? Knowing how to trace back, okay, well, the colon blood supply comes from the IMA, and that is because it is hindgut embryology, right? Like you can work yourself back into those problems, okay? So you don't even need to like memorize a lot of stuff if you can figure out how to understand the embryology, okay? And this little bonus lecture, none of it's on the test. It's just for if it helps you understand this a little bit better. That's all we're doing, okay? And for things like lymphatics and the immune system and like everything we've gone over so far, it's not as important. But for the things coming up, it is important, and you'll kind of catch on to that as we go. So, like, if you watch this, great. There's going to be points in the next couple lectures that you're going to be like, um, oh, that makes total sense because I watched the embryology lecture. If you don't watch this, there might be little things that we kind of go over, and you're like, that doesn't make any sense at all because I didn't watch the embryology bonus lecture. Okay, but if it helps you, great. If it doesn't help you, sorry for wasting your time. Um, you don't get your money back. Sorry, it's past drop out. So, so yeah, let me give you. I'm gonna give like a little primer, and keep in mind, I'm keeping this like super basic. I'm gonna only give you as much information as you need to like understand kind of where it comes from, and then we'll go from there. Okay. So, um, this right here, this is teachmeanatomy.info. This is a good website. Okay, I really like this website. Oh, and feel free. This is informal too. So like, if you guys are like, I don't get that, or this is stupid, then like toss it in there, shout it out. Like we can have a conversation about it. Like just you say we don't need to know this. Yes, you. Okay, listen. It's not on the test. It's gonna help you understand some of the stuff that is on the test. Does that help? Is that a convincing argument? Yes. Great. Somebody's getting an A. No, I'm just kidding. Actually, I'm pretty sure you have an A. I'm glad that you guys trust me. Just trust me. This is a test of trust. It is on the test, the trust test. Okay. All right, let's talk about embryology. Okay. So, little babies. Okay. And there's like pro features on this. You can go through this. All right, so little babies happen, okay? So you've got so you have an unfertilized oocyte. That's chilling up here, okay? So we've ovulated, we've kicked out an oocyte, right? And then some other stuff happened, and a sperm made its way all the way down the tube and went, oh, look, a little guy right there, okay? And so that happens, okay? Sometimes it's a mistake, sometimes it's on purpose. But you should know it's a 100% chance it could happen every single time. Okay. All right. So fertilized oocytes, that those start. This is an embryo at this point. Okay. Um, this is like right where it happens. This is conception, where life begins. Okay. Um, so it's a ball of cells. So it starts as cells and it divides. Obviously, it's one cell, so it divides into two cells. From there, it's 4 cells, and then 8 cells, and then 16 cells, and then 32 cells, and then a lot of cells. Okay, and that happens. I got a washcloth to wipe my movie eye. Aren't you guys lucky to watch me um, as a diseased person give a lecture off the cuff? So we're starting to build up cells. Okay, so we get a lot of cells, and then we have what's called a blastocyst. Okay, let's start with the blastocyst. None of this stuff matters. It does matter, but not really. Okay, so it implants in the endometrium of the uterus, and then it becomes a blastocyst. Okay, can I make this bigger? I can make this bigger. Okay, so this is a blastocyst, this whole like ball of cells right here. That's what that's called. Okay. Now from there you have an amniotic cavity, right? That forms like this is your egg yolk. I don't rub their eyes, so I don't get it. Wash your hands more. I should wash my hands more. The problem is I have a 1.5-year-old who sticks her grubby fingers in my eyes. Thinks it's hilarious. Um, And so, all right, so this is the amniotic cavity. Okay, so you have a little egg yolk right there. That's what that is. And in chickens, this big egg yolk. In humans, it's a little tiny egg yolk. Okay, and then from there, we have a disc, right? A disc forms. So like, don't think of this as a line. Think of it as a cross section through a disc. So if you're looking at a ball of cells, you cut it this way, and there's like a little disc right there. And the closest part is going to be the amniotic cavity, and then you have epiblast, and then you have hypoblast. So those two lines, these are two different cell types that are differentiating along this line. Okay. So from there, get out of here, Xfinity. Get out of here. Where's this one? Save the next. Inappropriate. All right. So from there, you have this little disc that forms. Okay. And then on the out from here, you have cells differentiating from the epiblast, and they fill in this middle section. Okay. So these are mesodermal cells right here. All right, so they start displacing these hypoblast cells and they form an endodermal layer. The hypoblast cells, they form an endodermal layer. The epiblast forms an ectodermal layer. So if you look right here, that's exactly what this is. So all this blue stuff is epiblast, right? And then you have the mesoderm right here that's like breaking out into and filling that space, okay? So that's what's happening there. All right. Now, from there, you're going to have structures that will be derived from those specific cell differentiations. Okay. So, your endoderm, and derm, right? These are all epithelial cells, okay? And that's why this is important because you're going to see this again in respiratory digestive, okay? So endoderm, you're going to have epithelial lining of the digestive and respiratory tracts, lining of the urethra, bladder, and reproductive system, and the liver and pancreas, okay? The mesoderm is mostly muscles and nerves, okay, in your brain and stuff. And then also the circulatory system will come from the mesoderm, okay? And then the ectoderm will be the skin, the epidermis of the skin, as well as the cornea and lens of the eye, which I hate right now, and the nervous system. Okay, so these are like this is like your central nervous system. This is going to be like your individual like little nerves. Okay, so let's look at that picture again. So ectoderm is going to be this right here, right? That's going to be your skin and stuff. Mesoderm is going to be your notochord, and the endoderm is going to be your digestive system. Okay. All right, and if it's digestive system, it's also a respiratory system, right? Because we just talked about how your digestive system is a tube, and then your respiratory, your lungs start budding off of that tube, okay? So endodermal cells, right, create the digestive system. So they're skin cells, kind of. They're dermal cells that are budding off, okay? So that's the first like 3 weeks, okay? And I'm trying to keep this super basic. There's a lot of other stuff that happens. All this blood supply stuff happens, but like just for the purposes of this little bonus lecture, um, you have 3 different layers of derm that are being formed. Okay, endoderm, mesoderm, and ectoderm. Okay, and they all come from the epiblast cells that migrate down. Okay, and if you want to know more about that, and I suggest you do, read through all these. Okay, so all right, that's all you need to know for embryology for the first couple weeks. Okay, now let's talk to go to a different one. Okay, right here. This is embryology med UNSW, which is somewhere in the United States, I think. I don't know. All right, so there's one picture that I'm looking for. Okay. So the amniotic cavity. So eventually that develops, right? Oh, that's not it. Yeah, that's this one. All right, so that develops, and then you end up with the amniotic cavity of the yolk. Okay, so this is endodermal cells. Okay, now from there, if this is the yolk, you're going to start developing that endoderm, and your digestive tract's going to like pouch out from there. Okay, and the invagination on this side, right? This gastrulation process. Yeah. So this gastrulation process, you can see it's like that tube right now, right? So you got a tube going all the way through, and this is all endodermal cells on the lining of that tube on the outside, okay? This is ectodermal cells on the outside of here, and then mesodermal cells are going to be on the inside here. We don't care about what's happening with the mesodermal cells at all right now, okay? But endodermal cells. So you're going to have the gastrulation in the blastopore or the blastocele. So blast is the ball of cells, and then cele is like a cavity, right? So you have a cavity within the blastocyst, and cyst is the ball of cells. Okay, so blastocyst is the whole ball, blastocele is the cavity, um, and then this cavity is called the gastrulation. Like that process is called gastrulation. At the end of this, you're going to have something called a gastrula. So you're going to go from blastocyst to gastrula. Okay. So that's why it's called gastrulation, because it's moving from blastocyst to gastrula. So that process is kicked off by the gastrulation process. Okay, so and that's probably way too many words. It's way more simple than that. But you have this little lining right here, and that's endodermal cells. Okay, so just remember that the inside of your digestive system is endodermal cells in human development, in most development. Awesome. Sorry, I have to do this because I can't see. Everything's blurry. All right. So let's talk about the endodermal layer of the GI system. All right. So from there, we start getting these little outpouchings, right? So if this is where the gastrolode starts and then it shoots across to here, this is going to be foregut, this is midgut, and this is hindgut. Okay. This will eventually start kind of folding and bending and pouching out, and you'll end up with all the different stuff in the digestive system. So you'll have a stomach, you'll have a large intestine, you'll have a small intestine, you'll have an appendix, all kinds of stuff. Okay, but that comes off the yolk stop. Okay. Let's see. Respiratory system. Okay, so just remember that the gut starts forming from the blastocele, and then at the end of that, you have gastrulation, um, which produces a gastrula. So at the gastrula point, you have a gut from the mouth to an anus all the way through. It's the shaky tube. Okay. Now, the respiratory system comes from the primitive gut tube. So when we're talking about the gut, right, we are not talking about this phase as much. We're talking about like here, where it's just like a tube all the way across. Okay. So from the primitive gut tube at week 4, we start seeing the respiratory diverticulum. Okay. The respiratory diverticulum is like a bud. Okay. So we've got this laryngeotracheal tube that starts developing here. Okay. And keep in mind too the order of development. Okay. So if something gets messed up in the larynx, it's going to affect something down the line. If something gets messed up in the lung, it might only affect that one lung. But if a problem starts up here, it could affect like this whole thing right here. All right. So we have this diverticulum that bifurcates, so you end up with these tracheal buds. And this is all going to become trachea. This is going to become the left and right bronchus, right? And then this is trachea, and then you have the bronchial buds. Okay. And it's growing from inside out, right? Like the cells are differentiating. They're developing here, like these little, where these little dots are. At the end of these, that's where the cells are like branching out from. Okay. So these are staying in place, and then these are just rapidly dividing. Okay, so you're ending up reaching it all the way out. So you're dividing, and then as they do that, they kind of create their own little branches off. So you have these bronchial buds and these bifurcations all the way along here as well. So again, keep in mind as we get to like this phase, so beginning in 4th week and ending in 8 weeks, as we get to this phase of development, if something gets screwed up here, it might only affect this, right? It wouldn't affect up here. Like this will develop normally and this will develop normally, but you'll end up with like a dysfunction down here, okay? And this branches out into all of the different lobes of the lung. Okay, so here we don't really have um, uh, like lungs per se. Like they're still, you're in the fluid, right? Like you're in the amniotic fluid, you're floating around. So there's no gas exchange obviously happening, which is why we end up with those circulatory system, the embryological derivatives that we were talking about earlier, right? Like the foramen ovale and all that stuff. So we're bypassing this lung system. but it's developing alongside. Okay, so the heart's developing over here, but I think the heart starts around 6 weeks. So it starts developing and then it pushes up against that. Okay, and that's the reason why we have pleura, right? So the pleura is just the inside of that outpouching or the outside of that outpouching. And then the other, so that's the visceral pleura. And then the parietal pleura is coming from development from another area. Okay, so the ribs are developing over here, and they have their own outer layer called the parietal pleura that will develop there. Okay, so this rib, that's enough rib. Ribs go like this. This rib right here that has a parietal pleura embryologically is different than the pleura right here, which is why we have a visceral pleura. Okay, so so those two things are developing completely separately, which is why we differentiate between those two pleura, right? Because that tells us where those cells came from. Okay. Um, so yeah, so we have upper lobe, middle lobe, lower lobe. Then this is the lungs. So 8 weeks, you have lungs basically. They don't do anything, but you have lungs, right? Um, let's see what else. So here you go. You can kind of see these are like problems that could happen. So a tracheoesophageal fistula is a direct connection between the trachea and the esophagus. So like this right here. So tracheoesophageal fistula. So if this never pinches off and you end up being born, what you'll have is you'll have a connection point between your esophagus and your trachea, which is bad because you're supposed to have an epiglottis up here that stops all that, right? So it'll go past the epiglottis and straight down in the trachea, and you'll choke and die. You can also have other congenital cases like tracheo esophageal septum. So you can have like a septum right here. So if you eat, it won't go anywhere, right? And then as you breathe, it'll go down into the stomach. Okay, and those can have different presentations. Okay, so it'll vary. So and within this, you can also have like partial fistulas or partial septum. So like they might be connected, but it might be just like a little strain or something like that. So um, they might, and you'll notice that stuff like super fast, like within days. Okay. So they might become cyanosed during feeding. They might vomit or regurgitate food. Keep in mind, like here, if they're vomiting, it's not always from the stomach. It could just be choking, right? Like it's coming up here. So there's surgical things that you can do to fix all these things. Um, let's see. Yeah, so ductus arteriosus shunts the blood from the pulmonary artery to the aortic arch, which will close in birth. We're supposed to. Um, there's no gas exchange going on. Keep in mind, there's no alveoli until 16 weeks. So they don't start developing until that 16th week. So this is not alveoli. It's just like smaller versions of lungs. Okay, that's basically what's happening. They're lung nubbins, pretty much. Okay, so week 16 they'll start kind of developing a little more differentiation. Okay, the first 16 weeks of development are pretty homologous among most vertebrates. Okay, so uh, they might become faster, but like that, as far as like what stage everything happens in, that's pretty much the same. So a lot of times you might see like a chicken embryology or something like that, and you'll be like, oh, well, this is a chicken. Why does it matter? Oh, because it directly relates to something going on in the human body, right? All right. So yeah. So each bronchopulmonary segment will become a specific portion of the lungs, um, and then it'll kind of develop during 8 and 16 weeks. Okay. Um, Towards the end of that, all these lung cells start to differentiate even further. So you get alveoli, you get basic simple squamous epithelial cells, which are what? Endoderm, right? And then simple cuboidal cells comprise the remaining 10%, and those produce surfactant. These are affected by COVID. That's what we're talking about. So there's just test questions and stuff like that. But that's pretty much what happens in the lungs during development. Okay. During the digestive development, other stuff happens, which we won't really go into because we'll go over that when we get there, but that'll help a little bit. But everything week 1 to 3, that's pretty important. And then knowing like where all this stuff comes from. When we get to the urinary system, that's wild. You'll see that. But all this crazy stuff happens. But we don't have to talk about that. I won't scare you with that. Any questions about development or embryology or how my eyes are doing? Because that's all I got for you. Keep it easy. And you're welcome to shelf this lecture and watch it in a couple weeks and be like, oh yeah, that's how that works. Let's learn lungs. Again, this will all make like way more sense once we start getting into some of the lung histology and you look at the cells and you're like, oh, endoderm. Okay, that makes sense. So that's all I got. I'll stop recording. And if you guys have any questions, just let me know.